Notation is key. So I have this video that is purely about notation. I did talk about it a little bit in the last video. We're just going to spend some more time on it now. And what I want to focus on first is this lovely table down here. And you've seen something like this previously, but I'm just going to talk about it again. And so you are encountering now, and for the rest of this course, symbols or concepts that appear to have two different symbols for it. But the difference is that one symbol corresponds to that concept when that numerical summary is calculated from the population, the big group of interest. And if that concept comes from the small group of interest, then it's from the sample and it's a statistic. If it's from the population, it's called a parameter. And so statistics estimate population parameters. And the way that I remember that is that S goes with S, sample statistics, and P goes with P, population parameters. And so statistics estimate parameters, which is the whole point of statistical inference. But before we get into inference, it's one of the biggest difficulties I find with students is being able to read the context and understand where that information is coming from so that you could assign an appropriate notation. And so that's what this lesson is going to be about. And so let's just jump right in. And we're going to take a look at number one here. A teacher is interested in determining the average IQ of students that enroll in high school calculus courses. He discovers that the average IQ of his class of 30 students is 125. It is well documented that the standard deviation of high school calculus students' IQ scores is 13.89. And so as I read through this, I'm doing two things. I'm figuring out which lines are referring to the population and which are referring to the sample. And then I'm thinking about, based on the values that are given, and sometimes the numbers are written, like TWO for 2 instead of the number. But in this case, they are all actually numerical values that we're reading here. And so what I'm doing is figuring out what am I given and what's the appropriate symbol for them. So again, as I go through, the teacher is interested in determining the average IQ of students that enroll in high school calculus courses. So that's very broad. That is signaling our population. Our population is all high school calculus students. Now, what he discovers is that the average IQ of his class, now his class is not all of the high school calculus students, maybe in that high school, but not all throughout the state or the nation. And so in this case, that 30 is the sample size. That's how much data we have for the sample. And the average of that sample is 125, and that's given in the same sentence. So that's going to be X bar because that average came from the small group, not the big group, the population. The next line says that it is well documented. So that is the signal that, hey, I'm about to tell you something with respect to the population. Phrases that are very broad or general, like it is well known, it's well documented, it has been shown historically, this is so. Phrases like that are cueing you in to listen carefully. I'm about to tell you something about the population. In this case, it says it is well documented that the standard deviation of high school calculus students' IQ scores is 13.89. So that standard deviation didn't come from the 30 students. It came from all high school calculus students, which means that is the population standard deviation. So now when I write those down, I know which symbols to use. N is the sample size, X bar is the sample mean, and sigma is the population standard deviation. Being able to label these correctly is important because what you're going to see in the next video is that the method that you use to analyze the data depends on what you have. And if you have sigma, you do one thing. If you don't have sigma, you do something else. But let's take a look at number 3. I'm going to skip one. It says a principal administers an IQ test to 20 randomly selected students. Among the sampled students, the average IQ was 108 with a standard deviation of 5. So what am I given here? Well, I know that 20 students were used. And so this is some school. I don't know if it's a high school, elementary, or junior high, but it's some school. And since he selected from his school, you may view the population as all students at that school. And that's a fair judgment. You could view it as all students in school, which isn't a horrible assumption, but I think at that school is fine. And there's probably more than 20. So among the sampled students, which is the 20, we know the mean and we know the standard deviation. So those two concepts, mean and standard deviation, came from the sample, which means that 108 is our X bar and that the standard deviation of 5 is S, not sigma in this case. And so that's how you could distinguish between what you're given, whether it's from the population or the sample. In the first one, we were told that it is well documented, and so that's about the population. And the second one, you were told that among the sampled students or from this sample, we learned this and this. And so that's what you're looking for. So it's really reading comprehension, but I trust everyone can do that. It takes a little time, but you'll get used to it. So at this point, I'd like for you to pause the video and attempt to write down what you know for problems 2 and 4 with appropriate notation. When you feel that you've got it, feel free to start the video back up to see what the answers are. All right, so let's see how you did. For number 2, past research has found. So that is signaling you this is broad, it's general. I'm about to tell you about the population. And what we learned is that the standard deviation of that population is 1.5 hours. So the appropriate symbol there is sigma. Sigma is 1.5. A sleep study recorded for 50 females, so that's your N, that had an average sleep of 9 hours. So that's X bar, because that 9 came from those 50 females. When we go to number 4, we are looking at a study that went to determine whether obesity among adult males is a major issue in the US. A sample of 100 adult male subjects, so that's your sample size, N is 100, was obtained and each subject's weight was recorded. An adult male is considered obese if he weighs more than 170 pounds. The mean weight of subjects in the study, so that's your sample. A sample was used in the study. The mean weight was 175 and 25 of them were clinically obese. So X bar is 175, but then you're given this information about 25 of them were clinically obese. And so that's 25 of the 100. And so if you're looking at the percentage that are obese, and this is the percentage of your sample, and you may not be familiar with that symbol, but you could go up to the table here. We're saying, okay, it's a sample, so the statistic for proportion or percentage is P with a hat on top or a caret. So what does that mean? It means that we've got P hat is 0.25. And that's everything that we are able to get from problem 4. So hopefully you did all right. It's good practice. You're going to get a lot more. It's just you're going to be making further progress with actually conducting inferential methods in the up and coming videos. Good luck.